Welcome to the Worldwide Center of Math. This is the second video in the video series going over the basics of mathematical proofs. In this video we will be discussing existence proofs, which are proofs which show that a solution exists or an example exists. And the two types of way to do that are non-constructive proofs and constructive proofs. Non-constructive proofs show existence or prove existence, but they don't provide a solution or an example, which sounds confusing, but I'll go over a quick example to show what a non-constructive proof is. So let's have our P statement, or our assumption be, let f of x equal to x squared minus x minus 1. And we want to show that f of x has a positive root. To do this, non-constructively, we will start by plugging in some numbers. So let's have f of 1. We have 1 minus 1 minus 1. So that's 1 minus 1 minus 1 equal to negative 1. Let's try f of 2. We have 4 minus 2 minus 1, which is equal to positive 1. And we have now shown that f of 1 is less than 0, and 0 is less than f of 2. And by the intermediate value theorem, which we can use because it's a proven mathematical fact, we can go from this statement to say that there exists an x where x is between 1 and 2, such that, actually, hold on, let's not get confusing. There exists a y where y is between 1 and 2, such that f of y is equal to 0. And since y is positive, since it's between 1 and 2, we have shown that there exists a positive root for f of x. And that is the non-constructive way to do it because we didn't necessarily find the positive root. We just showed that there exists one. Whereas if you were to do this constructively, you would just start off by saying, let y equal to 1 plus root 5 over 2, which obviously must be greater than 0. And then we just plug it in. So f of y is, let's see this. So we simplified, and then we'll simplify again, and we get 2 over 2 minus 1. This will simplify to 2 over 2. Oh, sorry, this is over 4. Now it will simplify to 2 over 2. And we get 0. So if we let y equal to 1 plus root 5 over 2, we plug it in, we find that it's the positive root. And this is the constructive way to show this because we provided the positive root. Another example of a constructive proof of existence will be to show that there exists, oh, by the way, I should probably mention, this symbol just means there exists. It's just one of those math symbols that we use in proofs. So there exists in x, y, z, which are integers. That's what the z means, in case you're wondering. Such that they are a solution to this equation. And the constructive way to do this would just be to provide an example. So let x, y, z equal to 1, negative 1, negative 1. Then we look here, we have 6 times 1 plus 9 times negative 1 equals 3 times negative 1. 6 minus 9 equals negative 3. Negative 3 equals negative 3. And there we go. We've shown that there exists x, y, and z that are integers such that this equality holds. And that is proofs on existence. For more mathematical proof videos, you can click right here. To subscribe to our channel, you can click here. To visit the Worldwide Center of Math or just the centerofmath.org, you can click here. And if you're on a mobile device, there will be an eye in the top right-hand corner of the screen with all of these same links. Thank you for watching.